All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm up 127's on the screen. Let's get started, please. And I don't know if you guys noticed, y'all. Look at number 5. Pre-calculus is here, y'all. Let's do this. Let's do it. We got this. All right, I'll give you guys some time. Copy and go. Then from there, you need a Cornell note. You do need a Ferri model because today we're moving on to a new function. Let's go. All right, Kimberly. All right, so before we get started with the warm-up, let's get this pink elephant out of the room. Next year, we'll get it back, yes? Powder puff, yeah? That's all right, it's all right. I mean, it happens. It happens. But now you learn from it and move on. You know what I'm saying? Dust it off and move on. So, with that said, because, man, imagine if I would have made that bet. Let's go. Oh, the seniors. Okay. Anyways, here we go. I'm going to zoom in, look up to the screen. Being that it's Monday, I'm going to go over all of these pretty quick just to make sure we're on the same page. Number 1, rewrite each expression. So, let me lower that a little bit. 3 to the negative 2, can we have negative exponents? No, so we send that to the denominator and it becomes 3 to the second. Put a 1 on the numerator. So this becomes 1 over 3 to the second is 9. Hands if you got that by yourself. Good. Distribute the exponent on the next one. So this is 1 to the negative third over 3 to the negative third. Now, can we have negative exponents? No. So that means we send this one to the denominator, bless you, and this one to the numerator. So this becomes 3 to the third over 1 to the third, which is 27 over 1, which is 27, or 3 times 3 times 3. So far, so good. Number 1C, you're like, Mr. Q, it's already simplified. Yes, but can we go backwards to rewrite it? Question. Before this came out of in here, what was that number in there? Tell your neighbor, what was that number before it became a 3? What was that number? That number was what, everyone? 9. So this would be square root of 9 times 5, which is square root of 45. That's how you rewrite that. So far, so good? Number 2, we got 2 to the x times 2 to the negative 3. Can we have negative exponents? No. 2 to the x over 2 to the third, and this is 2 to the x over 2 times 2 times 2, which is 8. So far, so good, yes? All right. Now, I'm bringing these back. These, for example, number 3A, B, and C, we already introduced these at the beginning of the school year. I'm bringing them back because I'm doing something else here. So let's see. 81 to the 1/2 is the same as, look up, 1/2 power is the same as square root. So that means 81, square root of 81. So what does the half mean, Mr. Q? Well, the denominator tells us what number times itself 2 times give us 81, and that number is 9. Therefore, what is this? Tell your neighbor. What is 100 to the 1/2? 100 to the 1/2, Jacob. 10, that is correct. And it looks like this. 1/2 is square root. Square root of 100 is 10. So far, so good? So, and once again, we're paying attention to the denominator because that's what tells us what number times itself 2 times. Look at 3C, though. This one's a little bit different. So I'm going to rewrite this first. Focus. Get off those phones. We got 8 to the 1/3 times 2. That's 2 in the numerator of the fraction. I brought it to the side. Therefore, look up. If 100 to the 1/2 was square root, because it's what number times itself 2 times, what do you think this is? It's cube root of 8. Cube root of 8. That means what number times itself how many times? 3 times. Then at the end, we take that to the second power. So question, what number times itself 3 times gives us 8? What was it? 2 times 2 times 2? Yes. 2. And then we bring the exponent of 2 next to that. What is 2 to the second? 4. All right, keep this in mind because these are coming with a vengeance in a little bit. Let's go to the last one. Let me zoom out so you guys can see how beautiful that looks. Look at that. Trig functions. Let's go. Oh, yeah, we got this. All right, let me scoot up. So, to get started with trig functions are based, look up, on a right triangle. What are they based on? A right triangle. What are they based on? A right triangle. Why is it a right triangle, Mr. Q? Well, because it has a 90-degree angle. What's so particular about these? That the longest side is always across from the 90 degrees. This one, put the wiggles on it. This is our longest side, known as the hypotenuse. Hypotenuse, the longest side. From there, what do we call the other two, Mr. Q? This one and that one are known as legs. Legs. So, we have a right triangle, and it's got 3 angles. It's got A, B, and C. So, sine, cosine, and tangent are based off this right triangle. So let me write my first formula. Sine equals, copy this please, op over height. Opposite over hypotenuse. Cosine is add over height. Adjacent over hypotenuse. Tangent is tan equals op over adj. Opposite over adjacent. Now, let's talk about the word adjacent. Adjacent means, look up, adjacent means next to. So, for example, if I was to be locating people over here, I would say Jacob is adjacent to Brandon Doherty. Because he's what? He's next to Brandon Doherty. Does that make sense? Yes, Mr. Q. So, adjacent means what? Next to. So, now that we have our formulas, look up. This is how we use them. They need to give us first an angle to focus on. What is the angle that they give us to focus on? Angle A. So circle that angle. All right. Now imagine you place yourself in this angle. So I'm going to draw someone with their back to us. They're facing the angle. Everybody see that? This person's facing that angle A. So think about it. Look up, please. Bah. This person is looking at angle A right there. Question. According to this person, what is next to them or adjacent. Adjacent. Now notice here on the formula, adjacent, focus, adjacent is next to this person. What's next to that person? Everyone, what would be next to that person? The 4. The 4 is next to. You're saying, but isn't hypotenuse next to Mr. Q? Yeah, but hypotenuse already labeled hypotenuse, so it can't be hypotenuse. The other side that's next to that person is 4. So with that said, I'm going to use these 3 formulas from the point of view of this person. So I'm going to write sine angle A. Write that down, please. Sine angle A. So here we go. I'm going to start all over. Look up. So these are the legs. All right. Question. Here's a person at angle A. Which one of these 3 is opposite to that person? Opposite to that person. Tell your neighbor. Which one of those is opposite? All right. Looks like Brandon Doherty's got it. Which one is opposite? 3. That is correct because it's all the way across. So let's write 3 right here. 3 for opposites. And it says opposite over hypotenuse. Tell your neighbor what the hypotenuse measure. Everyone? 5. That is correct. And that's how you set up your trig function. Let's go to the next one. Cosine angle A. Adjacent over hypotenuse. Tell your neighbor which one of these 3 is adjacent to this person over here. Which one is adjacent? Jacob, squared. Which one is adjacent? Five is the hypotenuse.
4.
Yes, that is correct. 4 over the hypotenuse, which is 5. And last one, tangent angle A. Tell your neighbor what it is. Opposite over adjacent. Still looking at it through the lens of this person. Opposite over adjacent. Tell your neighbor what it is. Danny, go. 3 over 4? 3 over 4, that is correct. And that's how you set up your trig functions. Students, introduction, pre-cal students. Yay, we got this. Anyways, copy the agenda, please. Warm up 127, exponential functions. We're moving on today. And for home plate 4 transformations. So, get a Cornell note. You do need a Ferri model, and also you need 2 coordinate planes from -10 to 10. All right, here goes the code for your, if you want to access this presentation. Here we go. 54VDM. 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 Once again, tonight you have 4 transformations according to this one. You'll see that once you log in. All right. Get a Cornell note. You do need a Ferri model and set up 2 coordinate planes from -10 to 10. I'll just give you some time. Go. All right, here we go. For the sake of time, I can graph and write exponential functions. So we are moving on to a new function known as exponential. So write that down in your Ferri model. Exponential functions, what are they? They are a function written in the form f of x equals b of x, or g of x equals a parentheses b exponent x minus h close parentheses plus k, where b has to be greater than 0 and not equal to 1, and the x is a variable. Examples: f of x equals x 10 to the power of x. F of x equals 2 to the power of x. And we've been seeing those in the last, 2 weeks on the warm-ups, yes? I was getting your brain ready with muscle memory. Let's go. Thank you, Mr. Q. You're welcome. I gotcha. G of x equals 5, parentheses 2, or base 2, exponent x minus 3, close parentheses plus 4. And g of x equals negative 2, parentheses 3, exponent of x, close parentheses. Copy that. All right, look up to the screen. It says, definition, exponential function. A function written in the form f of x equals b with an exponent of x. So, I want you to be obvious. Look up. Do this in blue. And label that base. Base. It's going to have a base, and it's going to have an exponent. Exponent. Exponent of what? X. That's why this is called exponential function. All right? Now, this is straightforward, a parent function. We've seen that in the warm-ups. Did I have you do plenty of work with f of x base 10x and f of x base 2 of x? Yes, Mr. Q. All right. However, the transformed function, look up, we still have a base b, still base, and we still have an x on the exponent. So that means the exponent is going to be a what? A variable. It has to be that variable x. Okay? Now, this is what they look like. This is what this one would look like transformed, or base 2 transformed becomes g of x equals 5, and then we got base 2, exponent x minus 3, and then plus 4, and we'll show you how that works with the general rule as well. Okay? So, look at them. Exponential functions, students, exponential functions. All right. So with that said, look at the non-examples. Look at this one. And look at this one. Tell your neighbor why these two are not exponential functions. Why are those not exponential functions? Look at them. Why are those not exponential functions? Now I'm going to pass that to Jay. He's going to enlighten us. Why are these not exponential functions? Tell your neighbor, please. Look at the examples. Look at the non-examples. All right, let's see this first one, Jay. Why is this one not an exponential function? In your own words, by looking at this one and this one that are, this one is not. Did everybody hear that? He said because the exponent is not a variable. And what is the exponent over here? A variable. The exponent has to be a what? A variable. Okay, this one is not. This one over here was a number. That's why that's not. Now this one, why is this one not an exponential function? Pass them on, Jay. Anthony D, why is this one not? Yeah, it doesn't have an equal sign equal to g of x or f of x. That is correct. So copy the hashtags, please. It has to be a function, so hashtag function. Hashtag as a base and a number, not 1. And the last one, hashtag the variable exponent. The exponent has to be a variable. Okay? All right, and I'm almost done getting ready your study guides for the final exam coming up next week. Let's go. We got this. Woo-wee. Let's go. But of course, we're going to go over the study guide together. So, everybody's going to ace it. We got this, yeah? All right. So, look up to the screen. This was the general rule. Look up. G of x equals A, f of 1 over bx minus h plus k. Remind your neighbor what k does, what h does, what a does, and what b does. Tell your neighbor, please. All right, Anthony D., pass someone. Who? Maya, what does K do? Up and down. How about H? Side to side. Pass someone for A and B. Right, and A does what? Stretches it or shrinks it in which direction? Yeah, vertical. Straight up, straight down. And B? Same but horizontal. All right. But now our new rule looks like this. Look up. Copy this new rule on your paper, please. This is our new rule for exponential functions. G of x equals A times B to the exponent of x minus h plus k. And once again, k still moves it up and down. H still moves it side to side. A stretches it or shrinks it or compresses it vertically, and B horizontally. However, circle K, that was good. See what I did there? Circle K, never mind. That's still our horizontal asymptote. Focus. You all right over there, Jacob? You good? All right. All right. So, keep that in mind because we're still going to use the asymptote for that. All right, let's go to our first coordinate plane. Right next to it, I want you to write this table, and it just says graph. We're going to graph. F of x equals base 2 with exponent of x. Make a table underneath with black. Next to that, I want you to do another table in green and label it g of x equals 2 exponent of x minus 1. Then one more table in blue, and this one is g of x equals 2, or base 2, exponent x minus 1, and then at the end, minus 5 outside the parentheses. Get that ready. I'll give you some time. Copy and go. Jacob, we ready? All right, good. Here we go. I'm going to zoom in. And we're starting with the parent function f of x with base 2 of x. This is a parent function. Look up, please, to the screen. Tell your neighbor how you can tell this is the parent function and not these two. Tell your neighbor how you can tell this is the parent function. How can we tell this is the parent function? Let's go. Kimberly said f of x. Let's go. That is correct. So let me zoom into the parent function. Here it goes. So let's fill in that table, and look how I prepped your noodle for this. Y'all ready? Here it goes. I'm going to write 2, and instead of x for the exponent, what is my first value for the exponent? -2, right? Can we have negative exponents? No, tell your neighbor how to rewrite this. How do we rewrite this? 1 over what? 2 to the positive 2 exponent. Yes, that is correct. So what is 2 to the positive 2 exponent? 4. So this is 1/4. That is correct. Ooh-wee. All that practice on the warm-ups. Let's go. Rebecca. All right, let's go to the next one. 2 to the negative 1. Tell your neighbor how to rewrite that, please, and what goes here once they rewrite it. Then we're going to go with Brandon. What is that value? All right. So 2 to the negative 1 becomes what, Brandon Felix? This is an exponent of negative 1. Could we have negative exponents? 1/2. That is correct. Or in other words, this goes to the denominator, 2 to the first. There it is. Next one, 2 to the 0 exponent. Tell your neighbor what 2 to the 0 exponent is. Everyone. Get it? Everyone. That is correct. 1. Continue. 2 to the first power is the same as 2. 2 to the second power, everyone. And 2 to the third power is 8. All right. So let me zoom out. We got our table full. However, to graph this, we started the same. Look up to the screen. I'm going to write my general rule on top so you guys can see it. Here goes. My general rule was g of x equals a times base b, focus, exponent of x minus h plus k. So look at this one and look at this. We have a base 2. We have an x. Question, do we have a k? Tell your neighbor, do we have a k for this one? No, so that means our HA is y equals to 0. So let's start with that. 0. And let's get our HA. There it is. And now let's plot our points on our coordinate plane. Negative 2 of x, 1/4. Negative 2, 1/4 is about right here. Next one, negative 1, 1/2. Negative 1, 1/2. 0, 1. 1, 2. 2, 4. 3, 8. 6, 7, 8, somewhere up here. And let's go from left to right. There it is. So what do you guys notice? Going from left to right, what happens to the values? They go what? Up. That is correct. They increase. All right. So, writing utensils down, look up, please. Let me pause the music. Writing utensils down. Here we go. Now that I graph my parent function, here goes the process. I start with my HA. From there, I look at the values. I use that for my parent function. But now for the transformation, I'm not going to use the table. But I am going to start with the process. Question, is there a K for this one? No, so that means my HA is still what? 0. There it is. Now I'm going to switch to green. Look up. Since there is no K, that means we don't move it anywhere up or down, right, Maya? As Maya said, up or down. However, tell your neighbor what's going to happen according to that. What's going to happen to that parent function according to that? Tell your neighbor. What's going to happen according to that? Then we're going to pass it to Anthony. What's going to happen to the parent function according to that? Now let me be obvious. Look up. I'm being very obvious right here. All right, Anthony, E, what's going to happen to the parent function according to that? It's going to move to the right. How many steps? How many steps, Anthony? Yes, one step to the right. Put a right arrow like that. Let's move all these points one step to the right. One to the right, 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 one to the right. So far, so good. All right. How we doing? Good? Next, go with a blue one. Look up. Again, we're not going to use the table. We're going to use this transformation. So first we need our HAY equals. Tell your neighbor what our HA is for this one. What is our HA? Looks like Bree's got it. Very good, Bree. Jazzy's got it. Very good, Jazzy. I see you. So let's have Anthony E pass it to someone. Who? Anthony D. What's our HA for this one? -5. Label that. That is correct. So we go 1, 2, 3, 4, 5. That's our new HA. And so we got this done. Tell your neighbor what's going to happen after we do that. What else do we do, Jacob squared? What's that? Down 5 and then? What? Oh, Jacob, 5 down and then? 1 to the right, that is correct. Yeah, because this one's still moving the whole thing down or up, and this one's still going to the right or to the left. So 1 to the right and 5 down. So let's do that to the one in black here. Here we go. I'm going to start with this one. 1 to the right, 5 down. 1, 2, 3, 4, 5. This one. 1 to the right, 1, 2, 3, 4, 5. This one, 1 to the right, 1, 2, 3, 4, 5. This one, 1 to the right, 1, 2, 3, 4, 5. And this one, 1 to the right, 1, 2, 3, 4, 5. And this last one up here, 1 to the right, 1, 2, 3, 4, 5. All right. So, students, exponential functions, students. Does everybody see now how each component works for the exponential function? Yes, Mr. Q. All right. So, from 1 to 5, I'll come to borrow you with transforming exponential functions up to there. Yeah, we got it, right? Okay. So, set that aside. Let's go to the next coordinate plane. Copy this table, please. G of x equals 1/3 exponent of x. make this table in green. And I'm going to write my general rule right above this. We'll do that here. G of x equals a times b to the exponent of x minus h plus k. For the sake of time, let's do this. We got 1/3 to the exponent of what? -2. Let me zoom in. Now, by now, we should be experts at this, yes?
Yes, Mr. Q, you gave us plenty of practice on the warm-ups.
So distribute the exponent here and here. So we rewrite it as 1 to the -2, 3 to the -2. How can I rewrite that? Tell your neighbor. Now I'm going to have Brandon enlighten us. How do we rewrite that? How do we rewrite that, Brandon Doherty? 9, that is correct. But how did you get there? Negative exponent goes on the denominator. This one in the denominator goes to the numerator. So this becomes 3 to the second over 1 to the second, which is 9 over 1, which is 9. Okay? Let's do it again. 1/3 to the -1. Distribute, distribute. That is 1 to the -1 over 3 to the -1. And it simplifies to what? Tell your neighbor. That becomes what, Trinity? Becomes what? 3. That is correct. Or in other words, that goes on the numerator, that goes in the denominator, and this becomes 3. All right, let's do the next one. 1/3 to the 0. Tell your neighbor what that is. What is that, Danny? 1. How about 1/3 to the 1st? What is that, Martin? Not here? Oh, Danny, again? 1/3, that is correct. And then what is 1/3 to the second power? Pass on one, Danny. Who? 1/9. That is correct. And 1/3 to the 3rd is 1 to the 3rd, 3 to the 3rd, which is 1/27. All right. Let me zoom out. Oh, my goodness. All right, here we go. Look up. Let's start graphing this. Question, is there a K for this one? No, so my HA is y equals 0. All right, next, plot our points. -2, 9, -2, 9, -1, 3, 0, 1, 1, 1/3, 2, 1/9, and 3, 1/27. They get smaller as we go. And what do you guys notice from left to right? That it's doing what? It's going down, right? So, let's wrap this up before the bell rings. Look up. Look at the base of this one. Look up, please, or you're going to miss it. Look at this base. And look at the function. Now look at this base and look at the function. Tell your neighbor what you notice. What do you notice? All right, let's wrap this up. On your general rule, if the base, hold on, is a whole number or a fraction, what happens when it's a whole number? One word. Increase. Yes, increase. How about when it's a fraction, everyone? Decrease. Yes. Have a good one, everyone. See you guys tomorrow. Bye. Later, guys. Bye. Have a good day. Bye. What? Oh, I'm going to give that out on Wednesday. What? And the final? Next week? Okay. Yeah, so I'll give it to you tomorrow.
Yeah, for sure. I was going to come to you tomorrow or the day after to grab my...
Study, guys.
So...
When you come back?
Thursday?
Yeah.